I'm not getting the right number somewhere. Hold on. 1.2318 minus 2.5 squared times by 1 times by 53 over 145 times by 1.5. 81 point, yeah, plus by 53 over 1160, 927.498. Yeah, 927.498 is 9 times 10 to the power minus 3. Let me do it again. Times by 153 over 145 times by 1.5. 881.8092. So 881.8092 power minus 3 plus 553 over 1160, 927.4989. Yep. Okay. So therefore, our IZZ, so this is also inches to power 4. So our IZZ will be equal to 1.1612 plus by 927.4989 times 10 to the power minus 3. So this is equal to 1.1612 plus 927.4. So it's equal to 2.0887. Okay, and this is inches to the power 4. Let me do it again. 2.087. Okay, so this is our IZZ. Okay, so now knowing this, okay, we are going to find our first moment of area. Now there are two ways we can do this. Okay, we can just focus on the steel. Okay, we can also focus on the aluminum. Either one that you use, right? The answer has to be the same. Okay, so now I'm going to take this. So there are two ways we can do this. Okay, so let me sketch. So it's our center is 1.2318. Okay, 1.2. So it's somewhere around here. So we know this distance is equal to 1.2318. Okay. So the location. Okay. So the let's see what they want us to find. So they want us to find. Okay. They want us to find the average stress at the bonded surface. Okay. So we're going to use the bonded stress at the surface, right? So we want to determine this red line over here. Okay. Now I'll show you the easier way of doing it first. Okay. So the easier way of doing it is we are going to use the aluminum. Okay. We are going to use the aluminum, right? So the one of the rules says that the analysis is in this direction. So the first moment of area we're going to take is this first moment of area. Right? Remember, the first moment of area cannot cross the centroid, right? So now we will have Q of aluminum is equal to N with depth Y bar. Okay, as I mentioned to you before, the aluminum or the width is the one that's changing. Okay, so the N is 53 over 145 times by the width, right? The depth did not change. The depth is still what? 1 inch, right? And then this distance, so the distance from here to here, this distance is equal to what? 3 minus by 1.2318. Okay, so 3. Okay, so this is 3 minus 1.2318, which is equal to 1.7682. Okay, so bracket 1.7682 minus by 1 divided by 2. Okay, why that's the case? And I know this is pretty long ago, not long ago, but because of your term test, we know that this over here and this distance this is your y bar. Okay, so with this, we know that this will be equal to 53 over 145 times by 1.5 times by 1 times by 1.7682 minus by 0.5 is equal to 695. Okay, 695.323 times 10 to the power minus 3 inches cube. Okay, right. So now we have already included. So this is n with that y bar. Okay. So now if we're going to find the Q or the shear stress, okay, shear stress of the what do you call that? Of the bonded surface. Okay. So we know that V is equal to what? 4 times 10 to the power 3. IZZ, we found that out, 2.0887 times by Q of aluminum, which is 695.323 times 10 to the power minus 3. Now over here, you just take the regular thickness, which is equal to 1.5. Okay. So 4 power 3 times by 695.323 power minus 3 divided by 2.0887 divided by 1.5 is equal to 887.727. PSI. Okay. Now, if we were to now, because on the bonded surface, now I'll use a different method. Okay. Right. Right. So now the bonded surface, right? Again, we're gonna let me see, can I? Squeeze it in a bit. Right. So now, if we are not going to use the aluminum now we want to determine using the steel. Right now, we are going to determine using the steel now. Now, I understand that the first moment of area crosses the centroid. It's okay. Okay. We are going to use the concept where on top, the first moment of area is positive. At the bottom, the first moment of area is what? It's negative. Okay. So now we are going to focus on using just the what? Just the steel. Okay, so now we are going to use the steel. Okay. So again, by looking at the formula, right, the shear stress is equal to V over I, and we know V over I is constant. And then we have your Q over what? T. The Q over here will be N with that Y bar. We know this, we know this, we know this, right? It's the Q we don't know yet. Okay. So if the concept is done correctly, the Q for the aluminum and the Q for the steel has to be the same. Or not, we're in trouble. Okay. So the Q, right, for the steel now is equal to the positive QZ of the steel minus by the QZ of the steel. Okay, so this is where it's positive, and this is where it's negative. And we know that N is equal to what? 1. Okay, so for the top, N is 1. The width is 1.5. The depth is 1.2318 multiplied by Y bar, which is equal to 1.2318 divided by 2. Okay, and then minus. Okay, so minus, we know that over here we have to find this thickness now, right? So this thickness over here is equal to what? 2 minus by 1.2318, right? So which is equal to 2 minus by 2318. Okay, 1.2318, which is equal to 0.7682. Okay, so the width, again, N is 1, the width is 1.5, right? The depth now is what? 0.7682. And then we have 0.7682 divided by 2. Okay, so this will be equal to 1 times by 1.5 times by 1.2318 times by 1.2318 divided by 2 is equal to 1.1379 or 1.13. I'll put more decimal point, 99 minus 1 times by 1.5 times by 0.7682 times by 0.7682 divided by 2. 442, okay, 0.5984 times 10 to the power minus 3. Okay, let me do the other 1 times 1.5 times 1.2318 times 1.2318 divided by 2. And if I will have this one, if I will have more decimal places, so it's equal to 1137.998 times 10 to the power minus 3. Okay. So as I said, the Q for the aluminum and the steel has to be the same. And I don't know now, okay? So 1137.998 power minus 3 minus by 442.5984 power minus 3 is equal to 695. Okay, 695.399 or 3 point or 0.4 or 399 times 10 to the power minus 3 inches cubed. So you see that this value over here and this value over here are very similar. Okay. So again, for the bond, right? So you have 4 times 10 to the power 3 divided by 2.0887 multiply by 795.399 times 10 to the power minus 3. Thickness held the same, 1.5. So 4 power 3 times 695.399 power minus 3. Power minus 3 divided by 2.0887 divided by 1.5, and